Have you ever looked up at the night sky and wondered what's really out there? We see tiny dots of light. What are those planets really like up close? For some planets, like Mars, we can send rovers with cameras. Rovers take amazing pictures of the rocky red surface, but some planets are completely covered in thick, swirling clouds. How can we know what lies beneath a blanket of gas no camera can pierce? It's a cosmic mystery. We can't just land everywhere, crushing pressures, scorching temperatures. So how do we map a place completely hidden from view? The answer is something truly amazing. We use a kind of supersight. So how does this incredible supersight actually work? Let's break it down. The word radar is actually an acronym: radio, detection, and ranging. Imagine you're standing in a big empty cave. You shout, "Hello?" A few seconds later, you hear your voice echo back. The time it takes for the echo to return tells you how far the cave wall is. Radar does the exact same thing, but with radio waves. A radar instrument on a spacecraft orbiting a planet, or a radar instrument here on Earth. It sends out a powerful pulse of radio waves that travel at the speed of light. They travel through clouds and even ice. When they hit something solid, they bounce back, and the instrument listens for the echo. One of radar's most stunning achievements was revealing the true face of Venus. For centuries, Venus was called Earth's sister planet because it's similar in size and mass, but it was a sister shrouded in mystery, wrapped in yellow, sulfuric clouds no telescope could see through. People imagined lush jungles beneath the clouds, but radar would reveal a far more shocking truth. In the early 1990s, NASA's Magellan arrived. Without a regular camera, its mission was radar mapping. For 4 years, Magellan sent pulse after pulse through the thick, poisonous atmosphere. Echo by echo, Magellan began to paint a picture of a world no human had ever seen. The mystery was finally being solved. Instead of a paradise, Magellan found a volcanic nightmare. Thousands of volcanoes and vast lava plains, strange coronae, collapsed dome structures, and tortured resurfaced terrain told a story of intense geology. Radar turned a cloud-covered dot into a real planet with a violent history. This changed our view of planetary evolution. Far out in the cold, distant reaches of our solar system, another mysterious, cloud-covered world was waiting. Titan, Saturn's largest moon, wrapped in a thick, smoggy orange atmosphere that completely hides its surface. Scientists speculated wildly. Maybe a global ocean of hydrocarbons like methane and ethane. Cassini arrived in 2004 with a radar instrument designed to see through the haze. As Cassini flew past Titan, its radar sliced through the atmosphere and revealed the surface. It didn't find a global ocean but dark, incredibly smooth patches concentrated near the poles. They looked exactly like lakes and seas on Earth. Radar confirmed seas of liquid methane and ethane. The largest Kraken mare is bigger than our Great Lakes combined. Radar even showed rivers, deltas, and a rain-driven cycle, an Earth-like hydrology but with alien chemistry. Titan transformed from a fuzzy orange ball into a compelling alien world and top astrobiology target. Mars has always fascinated us. We see its red surface, polar ice caps, and giant canyons thanks to rovers and orbiters. Billions of years ago, Mars was warmer and wetter, rivers and maybe even an ocean. But where did that water go? Much escaped to space, some locked as ice in polar caps. If liquid water exists today, it's hidden under miles of ice. Drilling is not an option yet. Enter radar. Marsis aboard Mars Express sent long wavelength radio waves toward the South Pole. In 2018, scientists found an unusually bright echo beneath the South Polar ice. On Earth, that bright return means liquid water. By analogy to Antarctic's subglacial lakes, the best explanation is a briny liquid lake buried a mile beneath the ice. The finding electrified scientists. Salty liquid could host extremophile microbes and renewed mission interest. Radar gave a specific target for future missions and fresh hope we might not be alone. Radar didn't just find water, it gave us a place to look. Our solar system isn't just planets and moons. It's filled with millions of smaller objects. From tiny pebbles to giant asteroids miles across, the leftover building blocks of the early solar system. Even our best telescopes often see them as tiny, blurry points. We can't tell shape, size, or surface from light alone. This is where ground-based radar astronomy, giant radio dishes, becomes vital. Scientists ping asteroids with radio waves and analyze the echoes to build detailed 3D models. It's like sculpting a statue from echoes a million miles away. Radar revealed bizarre shapes, Cleopatra like a dog bone, Itokawa a rubble pile shaped like a sea otter. Some have tiny moons, found by tracking subtle Doppler shifts in echoes. These models help protect Earth and plan missions to land, study, or even mine these bodies. Radar turns faint specks into unique worlds, giving us a family portrait of the small bodies that share our solar system. From the volcanoes of Venus to the methane seas of Titan and buried lakes of Mars, radar unlocked hidden worlds. Each time we peek beneath clouds or ice, we rewrite textbooks and spark new questions. Sometimes the most profound revelations come from listening to echoes in the dark. Imagine a radar orbiter mapping Europa's ice to find its vast subsurface ocean. Other icy worlds like Triton or distant Pluto may hide cryovolcanoes and buried oceans. Closer to home, radar will refine asteroid tracking, vital for planetary defense and resource knowledge. Engineers are already planning ever more advanced radar systems to probe deeper and farther. As we send radio wave echoes into the cosmos, the most shocking discoveries may be the ones we haven't imagined yet. What do you think we will find next?